The experiment which we will perform today is to determine the current sensitivity of a galvanometer of a given resistance and to convert it into a voltmeter of different ranges. So we will take the range of 1 volt and 0.5 volts. So as you know that we can convert the galvanometer into voltmeter while using a shunt resistance of low value. So this we will do. We'll convert the galvanometer into voltmeter of these two 1 volt and 0.5 volt range. The apparatus which we will be using is first is the galvanometer, which is deflecting from 0 to 30 and 30 from this side to this side, and the second one is the microammeter. This is DC from 0 to 500 microampere range, and then the third one is the voltmeter of 0 to 1 range. Okay, and then we need a DC power supply of say fixed range 2 volt 500 milliampere, and through which we will supply the power. And I need a rheostat of it's better to take 100 ohm, which will do work perfectly, and then I need a resistance box and some connecting wires. Okay, so the formula which we will be using is R equal to V by Ig minus T, because where this R is the series resistance which we need, resistance required to convert a galvanometer into a voltmeter, and G is the galvanometer resistance. So every galvanometer has its resistance. Like you can see, resistance of this galvanometer which we are going to use is 250 ohm. So this value we will be using here. G is the galvanometer resistance. Ig is the maximum current through the galvanometer for full scale deflection. So we have to find this Ig, and Ig we will be finding using this formula, which is K into N. K is the current sensitivity of the galvanometer, and N is the total number of deflection in the galvanometer. So total number of deflection in the galvanometer is basically 30. Okay, so we will find this current sensitivity, and then we will multiply it with the total number of division of the galvanometer, which will be 30, and then we can find this Ig. So we will use this Ig here. G we know, and V is the range of the voltmeter. So range of the voltmeter is 1 volt or 0.4 volt. So for respectively for these two we will put in here, and then use the value of this and this, and then we can find what is the shunt resistance required to convert this galvanometer of 250 ohm to a voltmeter, whatever range we required, 1 volt or 0.5 volt. Okay, so these two formula which we are going to use, and this is, let's come to the circuit diagram. This is a very simple circuit diagram, which is here we have a galvanometer, these two terminals of the galvanometer, and then you have a microammeter, and this is connected to a rheostat. So this is rheostat, this one which we are going to use, and this is our 2 volt DC supply. So we're not going to use the key here. You also need a key here to break the circuit. So first of all, let us make this circuit. So what we need is the galvanometer and the microammeter. This is for finding out the current sensitivity, this value K, so that we can take the Ig when multiplied by N to put here. Okay, so this is circuit for measuring the current sensitivity of the galvanometer. So what we have to do is we need a galvanometer. We don't need the voltmeter. Let us fix this here. We need a galvanometer, and then what I need is the microammeter. So first one is, you can see how to connect the circuit. So the first one is you choose any terminal. These are the two terminals of the galvanometer, and these are the two terminals of the micrometer. This is positive, negative. Galvanometer doesn't have positive, negative. It can deflect either this side or this side. So you can choose any terminal of the galvanometer, connect it with the negative of the micrometer. So I am choosing this of the galvanometer and then connecting it to negative terminal of the micrometer. Okay, so this going to the negative terminal. Then the positive terminal, this other negative terminal of the galvanometer is going to the this rheostat. So rheostat has two connections. 2 is below and 1 is above. So this is for the above and this is for the below. So that means the second terminal of the galvanometer is going to connect to the above terminal of the this rheostat. So let's connect it. So the second terminal of the galvanometer, this is like I have connected to the upper of this rheostat. So this connection is fine. Now we are left with the below connection of this, the other part of the rheostat. It's going to you can see through a key to the negative terminal of the battery. So this is the below connection. So I'll take this connection here and make it, and then it will go to you see this is positive and negative terminal of supply. So it will go to this supply of DC power supply. Okay, now this connection this part is done. Now this is remain. So the positive terminal which is left of the microammeter, you can see is going to this here. So this is common. So this is also coming to this place, and the positive of this is also coming to getting connected to this place. So you can make both either this point common or this point common. So what I will take is take the positive terminal of micrometer from here itself, so positive terminal of this to taking to the lower other terminal of the rheostat. So this is so the rheostat. Okay, and from here itself I'll connect to the positive terminal of the battery. So from here below itself, so I will connect it, and then this will go to the positive terminal of the battery. So this is the circuit for finding the current sensitivity of the galvanometer. Now come to the observation table. So I have this current I, which will be the first column, second column, deflection in the current. I will read from this micrometer 0, 550, 100, 150, 200, 250, 300, and then from the deflection of the galvanometer in divisions. Okay, because this is like 0 division 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 20, 25, and 30. So we'll measure these two from this circuit. So what I have to do now, I'm going to on the circuit. This is you can see the deflection in the micrometer as well as in the galvanometer. So I'll adjust the rheostat, and this by adjusting the rheostat I can make the galvanometer deflection to 0 first. Okay, so we'll make it 0, and okay, so there is a little bit of error of like 0.1 division here. Similarly, you can see that this is already almost at 10. Okay, 10, because you can see that this is the 100 is divided into 10 divisions, so this is almost 10, 20, 30, 40, 50. Okay, so 10. So and it's not 0, it's already 1 division. So now I'll start with the division 5. So I'll try to make this 0 to 10. So by adjusting the rheostat, while you are adjusting the rheostat, you can see there is a movement in the galvanometer deflection. So I'll make it to galvanometer deflection to 10. Just make 10. Okay, for 10 division in the galvanometer, what I'm going to have is the 100 microampere current. So I have to note it. So when I adjust the rheostat, by adjusting it, we make 10 division in the galvanometer, and then corresponding the current is 100 microampere. So I'll note it here. So for the 10 division in the microampere, so what I have is 100 10 division, we have 100 microampere current. Then I'll make it like you will make it 15 and 20. Let us make it 20. Let us make it 20. So because it's sensitive enough, so you have to be very careful. So it is almost. So it's almost 20, and then the corresponding current you can see, because this is like 180, or make it, if you'll make it full 20, it will go to 200. So that we will, for the 20 division, we will note down the current in the microampere. Like here we have measured for 20, this is 190. So similarly we will do it for like 25 and for the 30 division. Okay, we'll go up to 30 division. If we go to 30 division, so here for the full scale deflection, this is for 30, what we have is the 300 microampere current. So you will similarly, this is like 25, you will note it for 30, and then you'll write the microampere current. Okay, so this is when you are done with this observation, what you have to find, if you have to find the current sensitivity, which is K, and that is not equal to the I divided by theta. So whatever this you have, for 10 you have 100, so this becomes 10. For if you have 20, 190, you become 9.5. So this is the current sensitivity. That means the microampere per division, this K value is I by theta. So that is what going to give you the number of deflection per division in the galvanometer. Okay, so this is now, after this we take the mean value of this K value, sum all these and divide by the number of observation. So the current sensitivity is coming out to be 9.92 microampere per divisions. So once we are done with this, once we are done with the K value, I can multiply this by number of N, which is the division in the galvanometer. This is the total division is 30. So if I multiply this K, which is 9.92 with this 30, I'll get the Ig value, okay, which is the maximum current through the galvanometer for full scale deflection. So this is my full scale deflection, and then I put the value of Ig. G, I know this is galvanometer resistance, which I have told you, which is like, this is like 250 ohm written here itself. So, and then put the value of, for like, I want to convert it for 1 volt, so 1 volt, and then I find the value of R. So if I do this calculation, as you can see here, if I find the value of K, 9.92 multiplied by 30, I get this much of Ig microampere. And then, so for similarly, if I want to convert for the 0.5 volt, so I put the value of V, 0.5 volt. Ig I have calculated here. G is 249 or 50 omega. Actually, this is the value which we have measured by the multimeter. And then we put in the formula R equal to V by Ig minus this G. If you calculate it, you get the value of the R, which is the shunt resistance required, which have to put in series with the galvanometer to convert the galvanometer into the voltmeter. Similarly, in the same way, we can find it for 1 volt. Okay, everything will be same because the Ig is same, G is same. So for V 1 volt, now we'll put V 1 volt, and then for this we find this much of resistance R to convert the galvanometer into a voltmeter of 1 volt. This. Another thing what we need is K prime. This K prime is value which is just not just a multiplying factor. This is basically V by N. So V is the value for which we are going to convert the galvanometer, and then N is the number of divisions. So this is 0.5 by 30. This is the K prime. Similarly, if we are trying to change this for 1 volt, so this will be 1 by 30. Similarly, K prime for in case of 1 volt, this will be 1 by 30 division. Okay, so now let us try to make a circuit diagram for finding this is how to convert the galvanometer into ammeter. Earlier we have this galvanometer and micrometer at this place, if you remember this. Okay, now there is a series resistance here and the voltmeter in parallel. Okay, the addition is micrometer is not there, but I have a series resistance here, you can see, and a voltmeter is connected in parallel. and the circuit is the lower circuit remains the same. Okay, so let's try to make this circuit again. So first off the battery eliminator, disconnect all the things, and now so you see the conversion of connection of this circuit. So we have these two terminals of the galvanometer. The one terminal of the galvanometer is going to the resistance which we have calculated. So this R, for this R we are using the resistance box here. So this is my galvanometer. So I have taken one terminal of the galvanometer to the resistance box, one terminal, and then you can see the other part, another terminal of this resistance box. So the another is going to the negative of the voltmeter. Okay, so this is another terminal of this is going to the negative of the voltmeter. Okay, and then from the negative of the voltmeter itself, because this is a common point, this is common point, so from the negative of the voltmeter it's going to the connection in the rheostat which is above. So from the negative terminal itself, so this is from the resistance box, and the same connection is going to the upper of the rheostat, this one. Okay, not the below one. You can see this one is the connection. So this is done, and this from there itself, from the rheostat, the lower part connected to the negative of the battery. So you can see the lower part is connected to the negative terminal of the battery. So this part is done, and then what I have, the second part which is left of the galvanometer is going to the positive of the voltmeter. So the second is there going to the positive of the voltmeter, and the positive of the voltmeter is going to the lower part of the resistance. So positive of the voltmeter, this is another connection. Positive of the voltmeter is, you can see, is going to the lower part of the rheostat, and from the rheostat itself it's going to the positive of the battery power supply. So from here itself is going to the positive of the battery. So this is the circuit in which we are going to convert our galvanometer into a voltmeter of 0.5 or 1 volt range using the shunt resistance in series with the galvanometer. So we have already the table of observation contains the reading of galvanometer in divisions. So similarly we will do 5, 10, 20, 30. So what we have to do is we will do the same as we did. We will adjust the value of the reading 5, 10 in the galvanometer, and then we'll note down the corresponding voltmeter reading. So using the rheostat, we will adjust the value of 5, 10, 15, 20 in the galvanometer, and the corresponding we will note down the voltmeter reading, which is like you can see here written. Okay, V prime is K prime by theta. As you know, K prime we have already calculated for if we want to calculate per 0.5 volt. So we have V by N, this is 0.5 by 30, this is fixed. So this 0.0167 is getting multiplied by all the theta, multiplied by 5, 10, 15, 20, 25. So this is the V prime which we want to compare with the original value of the reading. Okay, so this is now is going to give me the voltmeter reading of the galvanometer which have been converted into a voltmeter of 0.5 volt range, and this is the original reading of voltmeter. So we will compare it, and then this will give us the comparison that how good the conversion is of galvanometer into the voltmeter. So what we do is, like, I'm going to on this supply. So now we can see the deflection here, so we will adjust all these deflections. Now first, before that, what I have to do is, like, let's just stop it. So for R we have calculated 0.5 volt. This is 1431.12 ohm. So what we have to do is we have to introduce this 1431 of omega into the resistance box. So let me introduce it. This is 1000. So then we have 400, then we have 20 and 1. So I have introduced 1431 of resistance into the resistance box. Now I will open the circuit. Then we will try to make the adjustments in the theta, try to make it like 10 in the galvanometer reading. So you can see in the galvanometer reading we have like, let me make it 10. So this is 10. Okay, this is 10. When this is 10, I have in the voltmeter reading like 0.16. Okay, 0.16. Okay, so I'll note it down that this is when the division is 10. So what I have reading is like here it is 0.18. What I am getting is 0.16. So this is 0.16 will be what I am getting 0.16. So which this is closer to this 0.167. Okay, so if we compare it, so it will give a more accurate value. Okay, so this is conversion, what I am taking 0.167. This is original value 0.16. And similarly, if we'll make it 20, let us make it 20. So if this is like 21, let me make it 20. So if it's 20, and then what I have is 0.32. Okay, so now we'll write it like when it is 20, what I'm getting is 0.32, and what is like 0.32 that is from original voltmeter reading, and what again is 0.334. So we'll compare it, and this is the difference is only of 0.014. In the same way we will go on doing for all the 0, 5, 10, 15, 20, 25 and 30, and you can see up to 30. We will note down the deflection and the current voltmeter reading, compare it with this, and that will give me how good the minimum difference is going to give me how good is the conversion of this galvanometer into a voltmeter of 0.5 volt range. Similarly, in the same way, we will introduce if you want to make it for 1 volt, so we will calculate the resistance for the 1 volt and then introduce the resistance corresponding to 1 volt, and then we again try to calculate the deflection and the corresponding voltmeter reading and try to get the comparison. So this is what we have to do in this experiment, in which we have to convert the galvanometer into an ammeter of 1 volt and 0.5 volt range. So result, you can write that the current sensitivity had been measured, which has come to be 9.92 microampere, and then you have converted the galvanometer into ammeter of 0.5 volt and 1 volt range. Okay, and the shunt resistance required for the corresponding 0.5 and 1 volt is this and this, and then from the table the comparison shows that the conversion is very good, and the value of the original reading is almost very nearer to the voltmeter reading by the converted galvanometer into voltmeter of 0.5 and 1 volt range. So this is all about doing this experiment, in which you have converted the galvanometer into a voltmeter of this range by measuring the current sensitivity of the galvanometer. Thank you.